Martine and give her a nice warm Journal Club welcome. So yeah, Martine, everybody. So my presentation is on the relationship between the mitochondrial enzyme, monoamine oxidase A, seasonal affective disorder, and bright light therapy. So for a bit of background information, seasonal affective disorder is a depressive disorder characterized by a decreased mood and drive in the fall and winter months, followed by remission in the spring and summer months. Statistically speaking, seasonal affective disorder is 4 times more common in women than in men, affects more people in the northern hemisphere than in the southern hemisphere, and is estimated to affect around 10 million Americans, and 10 to 20% may have more mild seasonal affective disorder. Around this time of year, we all start to feel a little down because the winter months are approaching, there's less sunlight, days are much shorter, it's colder, and it's totally normal to feel this way, but for people with seasonal affective disorder, the side effects are much more drastic. So, bright light therapy is the widely accepted form of treatment for seasonal affective disorder because it acts as an artificial light source when people do not have access to natural sunlight in the winter. In comparison, major depressive disorder is a depressive disorder characterized by a decreased mood and drive year-round. It is thought that major depressive disorder is caused by a decreased distribution volume of serotonin in the brain because serotonin is a key neurotransmitter that is thought to regulate mood, social behavior, appetite, sleep, digestion, among other things. Monoamine oxidase A is a mitochondrial enzyme that is actually responsible for the degradation of serotonin in the brain. So if there is a higher distribution volume of monoamine oxidase A, then there is a lower distribution volume of serotonin. So you may be wondering why I'm talking about major depressive disorder and this enzyme, because this is a presentation about seasonal affective disorder. Well, seasonal affective disorder is a subdivision of major depressive disorder, so it's thought that serotonergic changes can also underlie development in seasonal affective disorder. Previous research shows that there is seasonal regulation of the SERT receptor in serotonin, and it's altered in seasonal affective disorder, which means that molecular compounds found in serotonin are regulated by season and light. So if monoamine oxidase A degrades serotonin in major depressive disorder, it could possibly play a role in the pathophysiology of seasonal affective disorder and serve as a link between light, therapy, and treatment, which is exactly what my paper sought to answer. So does anyone have any questions right now? Okay. So the study aims to assess the relevance of the enzyme levels to the functional changes that accompany seasonal affective disorder, as well as the treatment of it, which is bright light therapy. So the big picture questions are: 1, if the distribution of the enzyme in the brain is different between people who have seasonal affective disorder and healthy controls or people without seasonal affective disorder. 2, if the enzyme is sensitive to bright light therapy, given that serotonin is regulated by season and light, and if bright light therapy increases serotonin, there would be a decrease in monoamine oxidase A. And finally, if there are any changes in the distribution volume of the enzyme between the fall and the winter and the spring and the summer, if participants with seasonal affective disorder are only depressed in the wintertime. So the participants consisted of 24 people with seasonal affective disorder and 27 healthy controls or people without seasonal affective disorder. Seasonal affective disorder is considered to be on the spectrum of axis-I disorders, which are usually categorized as mood disorders and eating disorders. Some examples are major depression, bipolar disorder, anorexia nervosa, bulimia nervosa, and more. And participants with healthy controls could not have any of these disorders, and then participants with seasonal affective disorder could not have an additional axis-I disorder. No participant could receive any psychopharmacologic treatment or bright light therapy for about 6 months, and psychopharmacologic treatment means that nobody could receive a medication that is meant to alter their mood. And finally, all participants were expected to keep up a regular daily routine so as not to tamper with the results. In order to determine if the participants in the study actually had seasonal affective disorder, a seasonal pattern assessment questionnaire was administered. This is kind of like what it would look like. It sort of asks you questions about how you feel during different times of the year. And all participants scored a seasonal problem score greater than or equal to 2 on the global seasonality score, on the seasonal problem score, and then a global seasonality score greater than or equal to 10 on this questionnaire, which basically means that if there's a number greater than 0, there's a level of severity for the participants with seasonal affective disorder. So in order to conduct the study, a positron emission tomography or PET scan was administered because they needed to get images of the distribution volume of the enzyme in the brain. In addition, they treated people with bright light therapy and placebo therapy in order to determine the impact of bright light therapy, if it's a neurobiological or a seasonal affective disorder specific treatment effect. So there was a PET scan administered in the fall and winter months prior to receiving bright light therapy or placebo therapy, and then after about 3 weeks of treatment, or what the participants thought was treatment, a second PET scan was administered, and then finally in the spring and summer months, long after the treatment wore off, a final PET scan was administered. So here are the results. As you can see, this is actually averaged between the participants with seasonal affective disorder and healthy controls, but you can see a decrease in the distribution volume of the enzyme in the fall and winter after the participants received bright light therapy, and an increase in the enzyme for people that received that didn't receive it.
I'm confused with the placebo. So bright light therapy is looking at the flame, like that light. How do people get a placebo of that?
So what they did was they took an artificial light source and they lowered the intensity of it, so it was not effective. They thought they were sitting in front of like a light therapy box, but it wasn't. Yeah. So this was actually taken with a PET scanner. As you can see, there was a decrease in the distribution volume of the enzyme in both the healthy controls and the participants with seasonal affective disorder.
So are they they're able with a PET scan to measure the enzyme levels?
They're able to detect the enzyme levels of monoamine oxidase. I'm not sure. I could go off on a whole tangent about how PET scans work, but it's like very complicated. But basically, they're. So these were the unexpected results. Because the participants specifically have seasonal affective disorder, the researchers predicted an increase in monoamine oxidase in the winter, reduction after bright light therapy, followed by normalization in the spring and summer. But instead, the participants with seasonal affective disorder actually showed no seasonal change, the way that the participants with healthy controls did. What's confusing about this is the fact that bright light therapy is thought to serve as like an artificial light source that will increase serotonin and decrease monoamine oxidase A. But this is sort of showing that natural sunlight is not doing the same thing. It's not decreasing the distribution volume of the enzyme. So, of course, the motivations for this study were due in part because major depressive disorder is a larger category of seasonal affective disorder, and there were serotonergic changes shown within that. So, they were thinking that seasonal monoamine oxidase A might serve as a link between light seasonal affective disorder symptoms and their treatment, but they did not receive the expected results, which is what makes this study a bit more complex. So we can see the efficacy of bright light therapy in decreasing monoamine oxidase A, but monoamine oxidase A didn't show any changes in the summertime. So there is now a thought that monoamine oxidase A is actually secondary to the changes in serotonin found in seasonal affective disorder, and there might actually be a physiological impairment in seasonal affective disorder. So this is a very important discovery. It complicates things, but it's just another step towards potentially curing seasonal affective disorder, which impacts so many people around this time of year. That's my presentation. Yes.
Can you go back to the PET images, please?
So
what's the difference between all these?
okay, so both of the participant groups, the healthy controls and the people with seasonal affective disorder, were receiving bright light therapy, and this is a scale that shows like the distribution volume of the enzyme, and after receiving bright light therapy, both the healthy controls and the participants with seasonal affective disorder showed a decrease the distribution volume.
They kind of all look the same. What am I looking for specifically here?
Well, basically, this just proves that bright light therapy is effective when decreasing the distribution volume of the enzyme in the brain.